Okay, today we're going to run a conjoint analysis on R. So I have my console open on the left and I have my script, R script open on the right. So you can see that I'm going to run each line by line on the script and you can see that how it runs on my console. Okay, so the first thing that I'm going to do is I'm going to run my data and or read in my data and kind of show you what this data set that I'm going to be working with. Okay, so I'm going to call this as conjoint 1, and if I show you what this looks like, it has a rating and it has some different type of attributes on make, miles per gallon, doors, and prices. It seems that it's a data set on an automobile. So what I'm using right now here is a rating-based full profile conjoint analysis, meaning that rating is my dependent variable, and full profile means that I have each of the attributes and each of the attribute has levels. And it's a full profile, and in this case I use a two level. So two level meaning that each attribute, make, miles per gallon, door, price, only has two levels here. Okay, and each of the corresponding attributes has a rating that a consumer has decided to give. So what are the each of the levels? So each of the levels is given as this, and I'm going to read in as a data frame here. So which means that for make, domestic is 0 and foreign is 1. And for miles per gallon, 22 is 0, 28 is 1. Two-door is 0, four-door is 1, and 22,000 is 0 for price, and 28,000 is 1 for price. Okay, so for a two-level full profile conjoint analysis, I can do this by running with regression. Okay, so if I were to run this regression, this is the results that I'm going to get. I could just look into the utilities, which is the estimate for each of the attributes. So you probably notice that these are the values that you need to look into. So for make, it has a 9.6 utility, miles per gallon has 30.4, and door has 14.9, and price has 40.6. So it seems that the price is the most important attribute, followed by miles per gallon and number of doors that you have, followed by the make. Okay. Now, this is using the traditional regression, and fortunately in R there is what we call a conjoint library. So I'm going to probably run this using my conjoint library this time and try to just to make sure that I get the same results. Okay, so what I'm going to do is I'm going to load my library for conjoint. Make sure you already have installed conjoint on your R package. Okay, so what I'm going to do is that I'm going to get utilities for my model here. And you probably notice that for conjoint analysis, model is the method that I need to call, and conjoint 1, the first column 1, this is your dependent variable, and conjoint 1, 2 to 5, you probably notice that this is your group of independent variables, or in our case, different type of attributes. Okay, so what I'm going to do is I'm going to run this part of code first. Okay, and you probably notice that I get a result that is very similar to what I get for the regression line. And you probably notice that factor is a little bit reversed by having minus. And if you look at the number, you could actually see that these numbers are actually 1/2 of what I get for the regression. So it seems that it's okay as long as you interpret it the correct way. And you probably notice that why is this negative? And in order to see that, you have to give in the levels for the conjoint method. So rather than using CA model, you could also use a conjoint method here. So once I run this conjoint method, now what I'm going to see is that I'm going to see that for each of the levels, it's going to give utilities. It also calls a part word. And the reason that it was negative, that it was that If you add domestic and foreign up, that happens to be 0, whereas for the regression case, it kind of considered one of the option as 0 and gave one of the other option a value. So 9.62 was the value. So no, 9.62 is the difference of the two. And you probably noticed that the difference of the two for domestic and foreign is again roughly around 9.62. Okay, and you can see that foreign is the one that is preferred because it has a positive utility. And you also notice that 28 miles per gallon is also preferred because it is also positive. And for number of doors, yes, 4-door is preferred. And for price, 18,000 is definitely more preferred than the 22,000. And the good thing about conjoint method is that you probably noticed that you have a graph and it gives you different type of graph in terms of importance for factors. It shows that the importance is most highest for price, followed by miles per gallon, and then door, and then make. And there's also several other different type of utility attributes that it gives. It gives for price. Let me try to move this to the left so you can see this for price, and also gives for door, and also gives for miles per gallon, and also gives for make, and so on. Okay. So now I could get the same value by running total utilities here. So if I were to run this, then okay, now I could see that I could get utilities for each of the combinations as a model. So remember, there were 16 different type of combinations for this example. So for all the 16 type of combinations, I can get the total utilities. It seems that the first one was 2.68, the second one is 43.3, and all the way down to the last one, which is 28 or 98.2. Okay, and I can also get the importance of each of the attributes. Okay, and these are the importance, and obviously you probably may have noticed this value up on this case right here, where you called conjoint. It's actually the same number. Okay, so conjoint is kind of like a summary of everything that you do, but if you want to just see the importance, you can call the CA importance method. Okay. Now, this was a 2-level full profile not a multi-level conjoint analysis, but just a 2-level. I know this isn't a really realistic case. So what we're going to do is go into a more realistic case here, and I'm going to read in a Excel file that has a more realistic case. And what I'm going to do is that I'm going to read in this smartphone conjoint. Okay, and smartphone conjoint is that now I'm going to have a different type of attributes for a conjoint for smartphone selections, and those attributes are brand, screen size, memory, camera, and price. And for brand, I have Apple, Samsung, other global and local brands. For screen size, I have 3.5 inch, 4.5 inch, and 5.5 inch. For attributes for memory, it's 32 gigs, 64 gigs, and 128 gigs. Camera, it's 8 megapixels, 12 megapixels, and price is going from $299, $399, all the way up to $899. So there's 30 combinations of attributes that a consumer can select. So that's the conjoint part. And on the data part, so each row is a consumer who has given a rating on the 30 of the smartphone combinations. Okay, so you probably noticed that the number of columns is 30 because there are 30 30 combinations of attributes that you can choose. And in terms of number of rows, I have 150 because 150 are the number of consumers that I have surveyed to evaluate and rate their smartphones. Okay. So what I'm going to do is that I'm going to read in this file, and I'm going to use the library Excel, and just to make sure that you have this. And for a smartphone conjoint, I'm going to call in the data sheet, and I also have the conjoint sheet here. So I'm going to read in two data sheets. So if I were to run this, let's just make sure that I'm running in. It has been running correctly. And I'm going to also read in or create the levels here. Okay. So I have created the levels for brands going from Apple, Samsung, and other global brands, local brands, and Inch, and so on. And I'll probably show you the levels as a data frame. And this is a data frame, so this is the levels that I see from brand, and you see inch, and you see memory capacity, and camera, and then for price. Okay. Now, the different thing that you could do with Conjoint Library that you cannot do for regression is that I could actually get utility for each observation here. Okay, so I'm going to do this for one line, meaning that for data for observation 1, it's probably a consumer 1. I just want to see one person at a time what I can get for their utilities. So if I were to just run this line, so now I see a utility for a particular user called 1, and it seems that this is the utility that I could get. Okay, and I see that it has a high preference for brand A1, which is Apple. Brand 2 is followed, which was Samsung. And brand 3 has the lowest by negative 5.6. Okay. And I can also see that each of the attributes and different levels by looking at the utilities here. Okay. I can use this by one, but if you want to go for the full model, what I'm going to use is, again, the conjoint method. So rather than getting just one value here, I'm going to use the full rows. And I'm going to use the conjoint matrix, and I'm going to use the levels as the third parameter. So if I'm going to call this, what it's going to do is that, okay, now this is the full model for all the observations. So now I could see that I can see the utility for each levels here. So for Apple, it has a preference of 11.2, followed by Samsung 5.3, and global brands is negative 5.7, and local brand is negative 10.5. So it seems that Apple, Samsung, global, and local, that's the ranking in terms of brand preferences. In terms of screen size preference, 3.5 inch is negative 9.6, 4.5 is 4.2, and 5.5 inches 5.4. So it seems that there's a strong preference for larger size, but there's not too much of a difference between 4.5 inch and a 5.5 inch, but definitely a negative influence or negative preference for a 3.5 inch. Okay. And also for memory capacity, 32 gigs is negative 4.4, the least preferred. And there's 128 is preferred by 2.32, but however not by much. But if you look at the utility for 64 gig, it's 2.1, so difference is very marginal here. And also for camera, you notice that negative 1.4 for 8 megapixels. For 12.2, yes, it's a 1.4, so 12 megapixels is preferred. And also for price, it's pretty natural that the lower the price that the people would prefer. So $299 has the highest utility, followed by $399, and all the way down to $899 has the least preferred. Okay. Now, you can see this by looking at the graphs here, because Conjoint prinouts the graph, and you can probably notice that the price is the most important, followed by brand, screen size, memory, and camera. So this gap or this value is representing the range of each of the utilities here. You probably notice that price has a highest difference in terms of utility. So going from 14.67 all the way down to negative 8.56, that's roughly around 32, so that's the number that you see here. That's why it's at 32. And price or brand is following price, And for brand, you have a 11.1 all the way down to negative 10.8. So the range is 31.52. So slightly lower than price, but it is still very much important. And that's the importance for each of the attributes. And however, but for each of levels of the attributes, now you can probably look at the graph and try to see which one was most preferred and which one was least preferred. And you probably notice that 299 is most preferred, and it goes down to 899, which was the least preferred. Okay, so now you can see that for each of the levels, and I'm just going to close this. And also you can call the CA importance, which is conjoint analysis important. And I believe you would probably see the same values that you got here for calling method conjoint. Yes, you probably notice that this is the same value that you get for calling conjoint method here. And one thing that I'm going to lastly add before we go is that you can actually run a k-means clustering on the observations, okay? And that is CA segmentation. And you probably noticed that this is a data variable and this is the conjoint matrix. And I'm going to make a three segmentations here, so three clusters. So if I'm going to call this, then now you probably notice that all the 150 observations are divided up into three clusters. So now you probably notice that some observations are going to one cluster, some are going to three, some are going to two, and so on. And these are the cluster means that you probably notice for cluster one. For question one, it seems that they have a medium level of 80.9 preference for question one, a smartphone, which I believe was an Apple smartphone. And you can see that for each smartphone, the 30 type of different attribute levels, they have a particular score. And based on that clustering, they have divided up into three clusters. So there's one thing that is actually a little bit more beneficial for using a library cluster rather than just relying on regression. So, okay, this is how you would do conjoint analysis in R. You would use the conjoint library. And hope this was a good tutorial on this. I'm going to post this on my webpage, so you can probably download the data set and the R codes and probably do yourself. Okay, all right. Thanks for watching.